So this is our finals review for semester 1. All right, so on Monday's final, we have 3 potential. The first 2 questions are graph questions. I'm going to remind you, it's chapter 7. So they're single lines. They are lines. They are not points. The first thing is that those equations could come to you in 3 different ways. They could come to you in standard form. Let me pause it. Hold on. They could come to you in standard form, like this. It could come to you in slope-intercept form, or they could be single variable equations on the coordinate plane. If you get an x equals, it's a vertical line. If you get a y equals, it's a... All right, so it could be a vertical or a horizontal. The 3 different ways that we graph, are with slope-intercept. We graph using both intercepts or using the table method. Okay? What takes the most amount of time? Table. So by this time, you know enough in algebra that you really should not be using the table method. What's the fastest way? Go. SlopeIntercept. SlopeIntercept. So SlopeIntercept is the fastest. I only usually use intercepts if they ask me or if the equation comes in standard form. Okay, so I don't know, I put it on pause, so you might have to hear a little bit of redundancy. So if we're graphing using intercepts, we're basically going to set x equal to 0, and when x is 0, we solve for the y, and we get y is 3, so we would get this point when x is 0, y is 3. I then plot that point, 0 across, 3 over. And then I do the same thing, I set y equal to 0. So when y is equal to 0, we get 3x equals negative 6, x equals negative 2. So then my other point is negative 2 comma 0. Remember, when we plot, our ordered pair is always go across first. So this is the across movement, negative 2, and then I go up 0. I connect the 2 points, and then I label my 2 points. If you can, label your intercepts if they're whole points, right? Okay. In terms of, this was just an example that I did down at the bottom. If you have a slope, I'm going to remind you, the upward movement is that rise. It's the rise. It's the numerator is the up and down movement, or we call it the rise. Rise over run. Run is the across movement. Whereas in the ordered pair, notice the across movement comes first. Okay? Okay, any questions here? I'm going to pause it. Okay. All right, so the second method of graphing was using slope-intercept. My personal favorite, it's fastest in my mind. So with the slope-intercept method, basically what's our goal? Get y alone, and we isolate the y, and then we find our slope and our y-intercept, our m and our b. Okay? So the first thing we would do is subtract 3x from both sides, and then we're left with negative 2y equals negative 3x minus 6. And then I'm going to divide all terms by negative 2. And this is something I kind of want to talk about. Notice it's negative 3 over negative 2. A negative divided by a negative is a positive. I have a lot of people messing up on that. Okay? And a negative 6 divided by negative 2 is also a positive. So now what is my slope, Lily?
Our slope is 3 over 2.
And our y-intercept?
3.
Good. Okay? So when I go to graph, I start on my y-axis, and you should be using a straight edge for your x and y-axis. Remember, we start with the b on the y-axis, 3. And then my slope is 3 over 2. So that's really your rising movement, your up and down movement, over your across movement. So it's a rise of 3. I'm going to rise 3 and run 2. Or I can go -3, go down, and left -2. So negative over negative really is a positive slope. And then we draw the line, label 2 points, hopefully your intercepts, unless your intercepts are going through a point. Okay? So just a reminder, your rise over run is your up and down movement is your rise. Are there any questions here? Remember, you still have to identify your X and Y axis. I wanted to talk to you guys about slope, negative slope, because I also have people doing, not doing this right. If you have like a negative slope, like -3/2, that means if it's in the middle, if it's on top, if it's on the bottom, that means that one of them has to be positive. Is up positive or negative?
Positive.
Is down positive or negative?
Negative.
Is right positive or negative?
Negative.
And what about left?
Negative.
Good. So when you have a negative slope, there's only one negative. If you have something like this, it's actually positive. So, you know, I could rise 3, run 2, and I end up here. Does that make sense? Yeah. So I just wanted to cover that because I still have people graphing the wrong way. A couple things in the Chapter 8 test were happening. A, they didn't check their work. And their work, they dropped a negative. And so then they put the line the wrong way. Yeah.
So when it's a positive slope, the line is like facing this way?
Yeah, think of money. Here's my money, and my money starts low and finishes high, right? We want our money to grow high, right? But if it starts high and then ends low, that's a negative situation, okay? We always read from the left, so left to right, the graph. So that's a positive slope. The other way is a negative slope, okay? Okay, did I see a hand up?
I was just going to say that you read a graph.
Yeah. All right, so is everybody remembering how to graph using SlopeIntercept?
Yes.
Okay. What about the kind of graphs where there are, what am I doing? The kind of graphs where you get something like x equals 7. How do we go about showing the work for that? It's a single variable, alphast.
So you got to label x and y first, the table?
Label a table. So we're going to show our work with a table. Go on. We're going to label it x and y, and then?
So you're going to label y 0, and then the x...
What do we label for sure when we are graphing a single variable? Go.
When the x column, since x equals 7, you're at 7.
X is always going to be 7. That's the only thing we know. 7, 7, 7. And we choose our y's. We choose the y's. It could be 0, it could be 1, it could be 2, it could be -1. And then I plot those points. And you should see a pattern. That's where you draw the line. Okay? You're still going to label 2 points and your x and y axis. Okay? Tell me about the slope of this line. Tell me about the slope. I don't know why I didn't stop. There we go. Okay, tell me about the slope. Yes, Louis.
Is it 0 slope? Or no slope?
Which one?
No slope?
Why do you say no slope instead of 0 slope? Emerson.
0 slope is when it doesn't rise at all, and no slope is when it doesn't rise at all and it's horizontal, and 0 slope is vertical. And
Yes.
Emerson said like correctly, but it's the opposite way around.
Okay, exactly. It's when x is when hold on. When your slope is 0 in the denominator, okay, hold on, I'm going to pause it, remind me. Okay, so basically, if you end up with 0 in the denominator, we call that undefined, okay? We can figure this out just by looking at the table. We can do it two ways. We can do the slope formula, right? And take any 2 points. Like I can take these two, 7, 0 and 7, 1. And I can say 1 minus 0 over 7 minus 7. Right? And when we see that 0 in the denominator, we call that undefined. Another way is, remember I told you that we can just do, it's going too fast. Pause. Hold on. We can just do the change in the y over the change in the x. So this is your change. What's the difference? From 1 to 0, what's the difference? 1. That's the change in the y's. What's the change in the x's?
0.
0. So you see the zeros there, then you say undefined. Do you understand? Or you can say no slope. Okay? If you end up with a 0 in the numerator, on the other hand, then you would say what? 0 slope. There is a value. Okay? Questions? This is the big thou shalt not divide by 0. Okay. Questions? All right, let's go on. So that was, we've now graphed 3 different lines. We've graphed using SlopeIntercept. We've graphed using intercepts. And I've showed you how to graph a vertical and a horizontal line. The next kind of problem is going to say find the slope. Find the slope. Who remembers what we do? Ethan?
You do m equals y 2
First tell me what I'm going to do. I'm going to use the
points.
go.
You're no label.
I'm going to use the, can anybody give me a sentence? Yes.
Point slope?
No. Yes.
Use the ordered pairs.
I'm going to use the slope formula. I'm going to use the slope formula. That's it. I'm doing slope. You need to use the slope formula. What is the slope formula? Don't just start naming things off. If you don't know the names, you won't understand the directions. Keep going, Ethan.
M equals y2 minus y1 over x2 minus x1.
And I don't want to see you write it like this. This is half of a formula. There needs to be an m, okay? So I'm subtracting 8 and 4. I don't know. I'm subtracting the 8 and 4, and then I'm subtracting the 5 and the 3. And what do we get?
M equals 2.
4 over 2, which is 2. Okay? All right. One thing I want you to pay attention, what happens if one of those is negative? Let's say the 8 is negative. Okay? I'm going to change this and now make it a negative. Sorry, I'm going to make it a negative, okay? If I make it negative, I usually like to draw these little lines. Do you see them?
Yeah.
And I just say, it keeps me straight. It's the first minus it's the second, the one in the second position minus the one in the second position. So it's always the same pattern. Keep going. And then I'm going to end up with negative 8. I just want everybody to be careful with their negatives. People are making huge mistakes that cost them a lot of points because in this situation, they're not simplifying correctly right here. Do you understand? So if you were to end up with something like 5 over 0, we would say undefined. But if you end up with 0 over 5, what do you say?
0 slope.
0 slope. M equals 0. You're going to use the number. Okay, is everybody clear on how to find the slope given 2 points?
Yeah.
Okay? The next part, I'm going to give you an equation and I'm going to ask you to identify the slope and the y-intercept. Okay, who can identify the slope and the y-intercept? Who have an Andrew? What's
The slope is negative 12.
good? Slope is negative 12 and the y-intercept, Turner?
B equals negative
Good. And if you give me negative 12x, I will mark it wrong. Because that is not part of, x is not part of the slope. It's the number that comes before the slope. All right, what about in the next one? How about Lily? What is the slope and the y-intercept? Y equals x.
M is 1 and B is 1.
M is 1 and B is what?
1.
Where do you see a 1 for B?
For the x equals y.
Y equals x.
Oh, I'm sorry. M is 1 and B is 0.
B is 0 because there's nothing there. Okay? Questions? I feel like those are 2 freebies on your test.
Yeah. Is there 2 of them?
Well, there's just one question that says name the slope and the y-intercept. I have people, especially in this class, that came up to me and went, what do I do? They're in the middle of their inverse operations and they're like, it can't be solved.
Yeah, it can.
What do I do? I'm just using inverse operations. So, Emerson, what do I do? Divide both sides by 5, and what do you end up with? X equals 0. It's not undefined.
0.
So x is equal to 0. Shh. Now, if I had, and let's say we're doing a system or something, and or substitution, and I get 0, then I can still substitute in 0. That's a substitutable number. Is that clear? We can find the ordered pair like y, it's 0, 5. Questions? Okay. All right. Next one is write an equation of a line given a point and a slope. And I want you to write it in slope-intercept form. Okay. So I'm going to give you a point and I'm giving you a slope. Okay. What would I do? What would I do? And I'd like to use my favorite method. Who can tell me what to do with my favorite method? How about Finnegan? Point slope. Thank you, because we're given a point and a slope. So point slope is my favorite when I'm given a point and a slope. Point slope. What is that point slope? Do you remember it? No, you said right. Y minus
Y1 equals M times the quantity of x minus x1.
perfect. And so I'm taping right now. Okay? So now I'm going to substitute. What would the next line read? How about Aram?
Y minus 4 equals negative 1/2 times the quantity of x minus negative 2.
Good. Okay? And then we distribute and get the y alone. Please write down these double negatives, not for my sake, for yours. Do you know how many people did wrong work because they dropped a negative in their head somewhere? Write it down. Give yourself a visual. Okay? So y minus 4 equals negative 1/2 times the quantity of x minus 2. All right. So now I can distribute. And then I'm adding 4 to both sides. I don't know why I did that. Okay. And we get y equals negative 1/2 x plus 3. All right. Now these directions said slope-intercept form. What happens if it said standard form? Would my method change? Okay, would it change, Logan?
Not exactly. You can just continue on.
We just continue on. You do the same thing. If it said standard form, and what would I do?
You would, you would add 1/2. You would add 1/2 x
To both
both
sides.
sides.
Good. We got to get the x and y on the same side. And then
And then you multiply
1/2 x by its reciprocal to make it a whole number.
By its reciprocal, okay. And we're going to multiply everything by 2. And that gives me x plus 2y equals 6. So it all depends on how I ask the question. I could say, write an equation of a line in standard form, or I could say, write an equation of a line in slope-intercept. Got it?
Yeah.
I might give you 2 points and say, find the slope, write the equation in point slope, take that as a point, then use the same equation, go to slope-intercept, then use the same equation, go to standard. Do you understand?
Yeah.
So you're doing just this process and give you, like, I don't know, 3 or 4 points for that. Okay. Now, you're going to do a similar thing where you're going to be writing the equation, only this time, instead of a point and a slope, you're given 2 points. So in this case, what would be my first step if given 2 points? If given 2 points, what would you do, Oliver? What? Find the slope. We don't have the slope, but we have the ability to find the slope. Okay? So we're going to use our slope formula. 1 minus 7 over negative 1 minus 5. Okay? I like to draw my little arrows. And then I end up with 6, negative 6 over negative 6, which simplifies to 1. At this point, what would I do next? Dion.
So you pick one of the points, either 5, 7, or negative 1.
Good. We're picking a point, negative 1, 1, and we're going to use the slope and use our point slope. What's that point slope formula again, Dion?
Y minus y1 equals m times the quantity of x minus h.
Good. Y minus y1 equals m times the quantity of x minus x1. What's the next line going to look like? How about Miriam?
Then we do y minus 1 equals 1 times the quantity of x plus 1.
That x plus 1, with you doing it, you're holding negatives in your head and doing a lot of work. So write it down so the visuals are here. There's way too many mistakes with negatives. Okay, I'm going to distribute. I get y minus 1 equals x plus 1. I'm adding 1 to both sides, and we end up with y equals x plus 2. If it says go to standard form, what would I do? Go, Ethan.
You would minus x.
Subtract x from both sides. Y minus x equals 2. Does it matter that I didn't put it negative x plus y? That's fine. As long as x and y are on the same side, it's in standard form. Quickly.
Just to make sure, where do you put m equals 1 and then negative 1, comma 1? Could you have put in 5, comma 2?
I could put in either of these original points right here. Got it? All right. The next part talks about parallel and perpendicular. You'll be given 2 equations, and I'll say, are these parallel or perpendicular? What do I have to do to prove parallel or perpendicular? Gideon.
The slope, to be parallel, it has to be the same slope, and to be perpendicular, it has to be the negative reciprocal.
Not negative reciprocal, opposite reciprocal. Doesn't always have to be negative. It has to be the opposite sign reciprocal number. But what do I have to do to figure that out? So he said, to be parallel, the slope has to be the same. To be perpendicular, they have to be opposite reciprocal. Aram, what do I have to do to figure that out? Get both equations to slope-intercept. So on the first equation, I'm going to subtract 2/5 x, right? And hold on. I'm just writing some directions. Just kind of reiterating what I wrote. And now, okay. So I'm getting my y alone. I'm subtracting 2/5 x. Now I'm left with negative 1/10 y equals negative 2/5 x plus 20. What would we do now? What are we doing now? Aram? Multiply everything by negative 10. Okay, and we end up with y equals 4x minus 200. Should be 200. I think I erased it. There we go. And then on the other equation, I'm subtracting 5x. And I get 10y equals negative 5x minus 5. Get the y alone. Y equals negative 1/2 x minus 1/2. Now, do I have to even look at the b? No. Is my slope the same? No. Is it parallel? No. Is it perpendicular? No. So it's neither. Okay? Yeah, you hold on. I can go back. Hold on. You want to go back? Okay. Yes. Okay.
Wait, so when you have the negative 1/10 y equals negative 2/5 x plus 20, did you multiply it both by negative 10?
I multiply all terms.
By
This is a term, this is a term, this is a term. Remember, I'm not multiplying the 1/10 and the y because these are connected. There's space, but that's one term. A term is connected by multiplication. It's separated by addition and subtraction. Okay? So, now, is this, now tell me, is this parallel, perpendicular, or neither, everybody? Parallel, perpendicular, or neither? Parallel. It might look different, but it's the same because they both equal 2. What about the next one? Is this parallel, perpendicular, or neither? Neither. It's reciprocal, but it's not opposite reciprocal. Next one. Perpendicular, parallel, or neither? It's perpendicular because it's opposite sign, reciprocal number. Now, there's the chapter 8 stuff. There's going to be let's see where we're at. Okay. The chapter 8, I'm not going over that because we just spent weeks going over chapter 8, okay? You'll have a substitution. You'll have some elimination, 2 elimination problems, okay? And, sorry, that was like supposed to be what are. Okay, chapter 8, you're going to have some substitution, some elimination. You'll have one where you have to graph the system. Okay, and write the solution. And then, so that's 3 graphing problems total. 17 problems and 2 word problems. The first word problem is it'll be like a digit and coin, or we might have a ticket problem, something from chapter 8. And then the second problem is back to chapter 3. It's the only thing really in chapter 3. Which is the sum of consecutive integers. So how do we set this up? That was supposed to be an X there. Okay. Does everybody remember what to do? Okay. What is the first odd integer? We call it X. Okay. What do we call the second one? Riley. Okay, it's odd. So, hold on. On the number line, if this were my number line, and let's say X is the first integer, what do I have to get to the next integer? Right. So if it says odd or even, you're going to do plus 2, plus 4, plus 6. Yeah. Okay? Odd or even. If it just says consecutive, what's the second integer going to be? Plus 1, plus 2, plus 3. Okay? So then remember, we're setting it up. If you don't set this up and identify your unknowns by now, you will not get any credit. I will not look at it. Am I clear?
Yes.
Got that? No shortcutting. I've spent a lot of time getting you to tell the story in algebra. This is your setup. Okay? And then we add up all the integers, x times plus the quantity of x plus 2 plus the quantity of x plus 4. I use the parentheses. It doesn't really change the value, but it just shows me that I have my 3 integers there. Okay, I'm adding all 3 x's up. Don't worry about this stuff over here. It was just a little. Okay. Somebody is asking again. Okay, so I'm adding up all my 3x. I have 3 x's plus 6 equals 189. Subtract the 6. 3x equals 183. Divide by 3. And x equals 61. So the first one is 61, the second one is 63, and the third one is 65. And here's how we write it in a solution set. All right. Yes, Amani.
So can you remind me of the when it says odd and if it says like even?
Right. So if they say right here, notice here it says odd or even. The first one's always going to be x. The second one is always going to be 2. Whether it's odd or even. Because if this is my odd, my first one, to get to from 1 to 3, how many do I have to add? 2. So to get to the next odd number, we have to add x plus 2. To get to the next odd number, what do I have to add? X plus 4 from the original x. Do you understand? And same thing for the evens. But if it's just talking about, let's say it's just consecutive integers. If this is x, what's the next consecutive integer? What am I adding to 1 to get to the next number? To get to the next consecutive. 1. So I'm going to take the original x plus 1. What do I add to the original x to get to the next number? Right. And this would be x plus 3, x plus 4. So only when it says odd or even are you doing 2, 4, 6.
But then if it says even and you do 2, 4, 6, does that make x 0 or 2?
X is the first one always. The second one is x plus 2. The third integer is x plus 4.
And if it's even, wouldn't that make x 0?
Nope. It would be the first integer would be x, the second would be x plus 2, the third would be x plus 4 if it's even. Yes.
So for showing your work, all you have to do is like the x equals first odd and x plus 2.
Yeah.
And then the equation.
The equation and then solve. Right. And then the answer.
And
Now,
then
this stuff off on the side was like a separate question that they were asking me.
You don't need the number line.
You don't need a number line. So a kid asked me, I think it was 4th period, why don't we have to distribute the positive in a situation like this, yet we always have to distribute the negative? What's the answer to that? Yes.
Because if you have a positive, like let's say you have like negative 10 and you multiply by positive 1, it'll stay the same.
Yeah, the value stays the same when we multiply by a positive, so we really do distribute. It just doesn't change its value.
And then if you multiply by negative, for like negative 10, it'll be positive 10.
Okay. Yes.
So x is always odd, or x is always number 1.
Yes, x is always okay, going back to the problem, yes. X is always the first odd integer. Or first any integer. If they say consecutive, if they say, unless they tell you otherwise, let's call the first one x minus 1, but I'm not doing that. Just know the basic consecutive integer problems. All right, so those are the questions that will be on your final. This is, wow, 34 minutes. This is it, and you can review this. You can do some practice problems from that chapter wrap-up or from the assessment. And that's it. Final on Monday. Optional if you do not want to take it. If you do take it, it will be added in.
That's actually not that bad.